This lesson covers static class fields, static methods, static constructors, and static classes. And we have been using static methods already in this course. So this is just going to expand what you know on that topic and introduce you to additional ways that you can use the static keyword. So static class fields. If you have a field that you would like all the objects to share, then you would need to make it static. So normally, when you have fields and you create an object, each object has its own set. But when you make a field static, there is only one. So all of the objects have access to that same field. One example of when you may want to do this is if you are counting the number of transactions, right? If you wanted the total number of transactions for the day, you definitely would not want the transaction field duplicated into all the objects, because then you'd never know what the total number of transactions were. You would want that transaction field shared, and that is what static does. So static is a great qualifier for any kind of field that you're going to use as a counter. So I've got a little example that illustrates the problem of not using a static field. So in this very simple little example, I have a class called accounts, and then I've got my program class. And in my account class, I have two fields. One is transactions, the other one is account name, and they are both private. So in my set transactions, I'm adding whatever number gets passed in. And then I've got a get transaction that just retrieves it. And then the set account name, I'm taking the account name that is passed in the parameter list and I'm assigning it. And I basically, in get account name, I'm just retrieving the account name that's there and returning it. Okay, so those are my get and set methods. Then in my main method, I'm creating three separate account objects. So you can see I've got one called account 1, I've got another called account 2, and I've got one called account 3. And then the first thing I do is pass a 1 to set transaction. And what set trans does, it just adds it into the transaction field. Okay, so it adds a 1 here, it adds a 1 here, and it adds a 1 here. Okay, and then I retrieve the account name, and then I call a print transaction method to print out the results. Okay, and the print transaction method is down here. It is static as well. Okay, and because it is part of the same class, right? I've got my class program here where I've got main and I've got print transactions. Because it's part of the same class, I don't need to prefix it with anything. I can just use print transaction and I can pass it the object. So you can see I'm doing that for account 1, account 2, and account 3. So here is some sample output. So I enter the name. For the transaction, I passed it a 1. And so then what it did is it printed out transactions equal 1 and the name is Flo. So for account 2, I key in the name Joe, and then it goes down here to call print transaction, and transactions is still 1. And then it prints out the name Joe. And then you can see for the third one, It's very creative names here. I've got Mo, and then when it came down to print it, transactions is still 1, and the name is Mo. So what if I want the transactions to accumulate? I don't want just a 1 printed. I'd actually, when we print out Joe, I'd like a 2 printed. And when we print out Mo, I'd like a 3 printed. Okay? In order to get that, I have to make transactions a static field. So to create a static field, all you have to do is add the keyword static before the data type. So you're going to have your access modifier, private, public. Then you will have static, you'll have your data type, and then you will have the field. Now you can initialize the field by setting it to 0, and it will only initialize it once. Okay? A static field is only initialized once, and it retains its value. Okay, so a couple of key points about static fields. They can be public or private. They can have any data type. They are shared among class objects. And local variables cannot be static. So what does that mean? That means any variable that you declare, like inside main, or maybe inside a block, that cannot be static. So how do I access a static field? You will use the class name followed by a dot and then the field name. So I reworked that program that we looked at earlier, and I made transactions static. So you can see it's still private. I added static before the data type, and I set transactions to 0. Then in my set trans method, I'm incrementing by 1. Get trans hasn't changed. It's still returning the transactions. And then my get and set for the account name, those have not changed. So the only thing that has changed is how I'm declaring transactions and the set trans method. Down in the main method, the only thing that's different is that when I call set trans, I'm not passing it a number. Okay, it's automatically going to increase by 1. Okay, and that is really the only difference in the main program. So here I am using account 1 to call set trans. Here I'm using account 2, and then I'm using account 3. The print transaction method has not changed, and neither have any of the other commands. So now the sample output, just because I made transactions static, the number of transactions does accumulate. So after I enter the first account name, it is going to show 1. But then after I enter the second account name, now it's going to show 2. And after I enter the third account name, it is going to show 3. Okay, so it is going to retain its value, and it is shared amongst the different objects. Now, what we were just looking at is how we would set up private fields. But if you remember, fields can also be public. And so public fields don't necessarily need, the get and the set methods, because you can actually access those from, any method that you're in. But this example is very similar. The difference is that I have made transactions public. Okay, it's still static. Data type is still an integer. I did keep the account name private. So you'll notice that I've removed the set and the get for transactions, but I kept it for account name because account name is still private. So how this is handled down in the main program, I still create my object. Okay, account 1 is my first object. And then because this is static and I want to access it directly in the main program, I have to prefix it with the class name. Class name is accounts, and then I do a dot, and then I give it the field name, and then I'm incrementing by 1. So instead of using account 1 to call the set method, I'm using the class and I'm accessing the field directly, which is what you can do when the access modifier is public. Okay, and the rest of the statement is the same. Okay, I'm still setting the account name. I'm still calling print transaction. The only difference is how I am accessing transactions and how I am incrementing them. And I do the same thing for account 2 and account 3. Now down here in print transaction, I do have to retrieve the transactions. In the previous programs, I had to call the getTrans method because transactions was a private field. Now transactions is public. So I do not need the get method for transactions anymore. So you'll notice that I am accessing the value using the class name accounts, a dot, and then transactions. There is literally no difference in the output. Okay, I'm still incrementing the transactions with each object that I create. The only difference is how I am accessing the data in the field, how I'm retrieving it, and how I am changing it, how I am setting it. Okay, and with a public static field, you have to use the class name, a dot, and then the field name. So that is static fields. Now we're going to move on to static class methods and constructors. Now we have been using static class methods for several weeks. And so we're going to take another look at those, and we're going to expand on what we know by also looking at static constructors. So to create a static method, if there is an access modifier, right after the access modifier, you put in the keyword static. If there is no access modifier, then static goes at the beginning, followed by the return data type. And that is all you have to do to make a method static. And if you remember, if there is no access modifier, the method is private. Okay, and the method can be either private or public. So how do we use a static method? Well, it depends on where that method is created. If it is in the same class as the method that is calling it, okay, then we access the method using one technique. And if the static method is in a different class, then we have to access it using a little different technique. So first we're going to take a look at how do we access a static method if it's in the same class. Okay, and this is probably the easiest scenario. Okay, so we have here a class called program. In program, we have our main method, and then we have a method called find max. We also have find min and cube. Okay, so those are all methods that are in this program class. Now, because find max, find min, and cube are all in the same class as main, if we want to use any of them, it is just simply the name of the method, and then in parentheses, we pass it the data that it needs. Okay, and this is pretty much how we have been coding our methods up until this point. They've all been static, and this is how we have been calling the methods and passing data to them. Now, it is a little different if the static method is in one class and the calling location is in a different class. So when that happens, you end up having to use the class name, a dot, and the method name. So you have to tell it the class that the method is located in. So let's take a little look at this example. We have a class called calculations, and you'll notice it's public, which means that it can be called from anywhere. We also have 3 public methods. They're all static. One is called find max, find min is another, and cube. So what it means when these are static methods is that you do not need an object to call them. Normally, if you are going to call a method, an object has to do it. And that is why you have to put the name of the object, a dot, and the method name. But if the method is static, you do not need an object to call it. So in our calculation class, we have 3 static public methods. In our main programming class called program, we got our main method, and we want to call these static methods that are in the calculation class. So anytime we want to call one of those methods, we have to use the class name, calculations, and a dot, and then we use the name of the method. So calculations.findMax, calculations.findMin, okay, or calculations.cube. Okay, so the key thing to remember is that if you have a static method and it is not in the same class as the program you are writing, you will have to use the class name, a dot, and the method name to access it. So last week we talked about classes and we talked about constructors. And the purpose of the constructor is to initialize the fields in the class. It makes sure that the fields are set to valid values. So if it's a number field, it is set to 0. If it is a character or a string, it is set to a blank. Okay? If it's an object or if it's an array, you can set it to null. Okay? That is the purpose of a constructor. If you have a static field, then that field needs to have its own static constructor. All of the other fields that are non-static will go to the non-static constructor. So what this means is you have to have 2 constructors. You have to have one for your static fields, and then you have to have one for your non-static fields. So this example is showing that I've got 6 fields. 1 is static, okay, transactions. The other 5 are not. So you'll notice I have 2 constructors. If I have a static field, it has to have a static constructor. So I do need to put the keyword static in front of balance. Okay, and then I set transactions to 0. For the non-static fields, this is just a normal constructor. I just use balance, and then I take each one of the fields and set them to blanks or zeros. Now, it has been our convention that when we have a private field, we start it with an underscore. Okay, that's how we've been starting the names. And this has been done so that we don't have naming collisions, so that when variables are passed in the set methods, that we don't have the same name being passed as the field that we are trying to assign the value to, because that tends to confuse the program. So when you put the underscore in front, it makes those private fields uniquely named. Okay, so that is why we do it. There are many languages that don't follow that convention. And depending on what a developer's background is, they may not follow that convention. Okay, so you may see a scenario like this, where you've got fields defined in a class and they don't have an access qualifier, which means they are private. Okay, and you'll notice that they don't begin with an underscore. So then any kind of a set method or a constructor that is pulling in the parameters could very well have a parameter named the same as our field. And you can see that that has happened in this example. And in real life, that also happens. So this is fairly realistic. In order to tell the program which variable name belongs to the field and which one belongs to the parameter, we prefix the field with the keyword this. That is referring to the object. Okay, for a parameterized constructor like this, the only way this is going to be executed, let me pull up a handy dandy example here. The only way this is going to execute is if I create an object, right? So if I have a student class, and I'm going to call it student 1, equal to new student. And then when I create this particular object, I'm going to pass it some data. So I'm going to pass it an ID. I'm going to pass it a name. And, oh, how old should Fred be? We'll make Fred young. And then let's see, subject. Oh, he's going to do programming. And let's see. So we've got his ID, name, age, and subject. Okay. So we've created this little object, student 1, and when we created it, we're passing it data, so it's going to run through this parameterized constructor. And you'll notice that coming in for ID is the number 10. Coming in for name is Fred Flintstone. So this is the data we're passing, and this is the object. So when we create an object, okay, the object automatically has the fields that are in the class. So student 1 ID, student 1 name, student 1 subject, student 1 age are all part of the object. And when we're in the constructor, the object is prefixed with this. So this dot ID is referring to student one ID. This dot name is referring to student one name. This dot subject is student one subject. Okay. And then ID is the ID getting passed. So that's 10. Name is the name getting passed, Fred Flintstone. Subject is programming one. Okay. And age is 25. Okay. So we use the keyword this to identify the object. And that will help differentiate our fields from the parameters. And you will see this in a lot of languages. Null. So null basically is the default for nothing. It's like an empty reference. And we've talked about value types like double, integer, character, short. And we've talked about reference types like strings and arrays and objects. Reference types can be set to null. Value types cannot. So when you're initializing, if you're initializing an array or you're initializing a string, you can set it to null. That is allowed. Okay, but if you are initializing an integer or a double variable, you cannot set them to null. Okay, you would have to set those to 0. Static classes. So static classes are kind of interesting in that you cannot instantiate them. So what does that fancy word mean? If we have a static class, we cannot create an object. Okay, if student was a static class, I could not create a student one object. Okay, when I create an object from the class, I am instantiating the class. I am creating one instance of student. Okay, and if you have a static class, you can't do that. So why would somebody even create a static class? The math class that we have been using methods from, like rand and what's other ones? Round. I mean, there's just a ton of math methods that we've used. Okay, that class is a static class. System convert, where we've actually used that to convert, string to integer and that type of thing. That's a static class. Okay, so static classes are used. And the key for the static class is that you cannot create an object of the class. So in a static class, all of the members have to be static themselves. So if you make your class static, that means all the fields have to be static, and so do the methods. The only constructor that you can have is the parameterless constructor, which is the default one. So to illustrate how this works, just so you understand the difference between static and a normal class, I have two different classes that I've defined. I have a regular class called college student, and you'll notice that I've only got two fields, ID and name. And then I've got a set ID and a get ID and a set name and a get name, even though they're public. Okay, I went ahead and did the set and get. And then I've got a little student detail method where I'm formatting a text string and returning it. So that is my little college student class. Okay, so that's just like a normal one. Then I created a static class. And so the key being that the keyword static is after the access modifier, so it's public static class student. Because it is a static class, that means that the fields have to be static. And then the methods have to be static. So the get and the set, and even the student detail method all have to be static. Okay, so this is basically a duplication of my first class, but now everything is static. So in the main program, we are first going to use the static class. Because it is static, I cannot create an object. So, how do I put data into the ID and the name? I do a direct assignment statement because these are public. That means that even though this class is student and my main method is in the program class, okay, they're in different classes. Because it's public, I can access the field using the class name of student, a dot, and then the field name. Okay, so it's a static public field, and I just use student.id, set it to 10, student.name, set it to Scooby-Doo. And so that's how I access the fields. How do I access the student detail method? Kind of the same way. I'm using the class, a dot, and then the name of the method. Okay, so there's no object involved. I have to use the class name instead. Now for my regular normal class, right? It's non-static. Here I do create an object. It's a college student object called new student. And I use new student to access ID and name. Because if you remember, ID and name are public. And then I also use the new student object to invoke the student detail method. Okay, so that's the primary difference. In a static class, you don't create an object, so you can't use the object to set any of the fields, and you can't use the object to call methods. Okay, but in a non-static class, you do use the object, and that is the difference.